Hi everyone, this is Neil Bulger, and welcome back to Calculating Building Peak Loads with Trane Trace. We are going to jump right into how to assign and look at HVAC systems in Trace and run our load calc. We're going to continue using the model I've been building of our office, which now is up to 3 rooms. It's quite impressive. And give it a go. So let's start right in. So in Trace, go ahead and click on Create a System. And in here there are a lot of systems to choose from. This list is constantly being updated by Trace. And so you're aware, the reason there's a lot of these systems is because Trace has another component of software called Trace Energy, where Trace actually has a full energy simulation interface, and a lot of these systems are more detailed there and can be used there to simulate performance of a building. Because the softwares have a similar front end, Trace just copies that list to both places. There are different nuances if you were to dive into how Trace loads is using these different system types. Generally speaking though, I would really recommend sticking to a few system types or even 1 or 2 system types and letting Trace do as little as possible in the manipulation of the building peak cooling and peak heating loads. In my opinion, the peak loads are a very straightforward calculation, and when you start to involve the nuances of a system and how one coil is conditioning the air and then another, that's getting ahead of yourself or even ahead of this calculation and can be confusing, especially if you're looking for a starting spot. So let's go ahead and get started. We're going to call this System 1, just to be generic. By default, Trace picks this VAV with baseboards. I would really recommend always changing it to variable air volume and then going down to VAV reheat 30% minimums. This setup I have found to be the most robust system in Trace that will do the least or no changes to your building's loads when it runs. Each room gets what it needs and it should work fairly well. There are other ones. For instance, I just noticed 90.1 system types are here. There are chilled beams, and I will talk about the chilled beam 1 and these passive chilled beams for understanding load calcs of radiant systems in a follow-up video to this next. But to start with, let's go back to variable air volume reheat. So there are a lot of tabs in Trace. At this point, we could just hit close and we could run our model and at least see a load. I'm going to go through some of these tabs first just so you're aware of what's on them, and then we're going to apply our rooms. So to start off with, before even going further than this, there is this advanced button, and behind this there are a lot of options to be aware of. So definitely click on advanced every time you set up a system. In here are things like, where's the return air path? For instance, do we have a plenum? Would we expect to see loads in that plenum? Maybe we don't. Maybe we have a room direct return. There are fan configurations. The reason we care about fan configurations has to do with the fan motor and if it's contributing heat into the building and if that heat needs to be relieved by the cooling coil. It has some other questions about cooling coil size. Generally, the two I would recommend looking at are the return air path and these ventilation ones. Down here, system ventilation flag. By default, Trace will be set up to system ventilation flag sum of rooms. So when it sizes the building's fresh air needs, it looks at all the rooms together and adds up their outside air needs. It is possible to do ventilation calcs inside of Trace and I do recommend it if you are considering all air-based cooling and heating systems, where you can actually have Trace do the 62.1 calculation. That in and of itself is a very complicated standard that has to do with ensuring each room has enough fresh air at all times, and the system is balanced to do that. If you do want Trace to go through that calculation process, you would turn this on here. Again, I would recommend sticking to the sum of room outside air even first, even if you are going to have Trace calculate 62.1. Run the loads model first with only the sum. Again, this is sort of to mitigate any problems that might appear elsewhere in the model and ensure that things are set up right. Run it once, look at the numbers. Yep, looks good. Then go deeper. Moving on. There are ways to add special coils and options, economizers, evaporator types. I would really recommend not using any of these. In Trace, again, I recommend doing a lot of calcs outside of Trace. The advanced options is where there are some toggles we may want to look at. We're going to come back to this, but auxiliary coils, this has to do with dedicated cooling systems, be it radiant, chilled beams, or L. There's also this ventilation overrides area. Before I was showing you where that ventilation toggle was between sum of air and other. Here again, it's saying it's doing the sum of the rooms, yet it is possible to change this and say, actually, I know that I always want to have a fixed fraction of the air be fresh, and once I'm going to say it's always 70% of all the outside air. You could do that here. This comes up on a certain set of scenarios, and your manager or helpful designer can bring that up. I would start with sum of room airs. But it is sometimes helpful to say, no, I know that I always want 30% of my fan size to be outside air. So that can be a good thing to use. Okay, moving on. Dedicated outside air. Let's come back to this after we look at this schematic. So just know that the dedicated outside air system is not an easily understood coil. It's doing some strange things. Let's come back to that. Temperature. Here's where we can put in the maximum supply temperature for cooling and heating. Let's say I knew I always wanted to supply 55, and for heating I only wanted to supply 90. If I did that, I would now be set to go. And if you actually notice, I picked cooling supply, not necessarily leaving cooling coil. You can pick either of those. The difference being, if the fan is between one of these nodes, the fan heat might need to be accounted for and would be accounted for. Anyways, I'm going to keep going. Fans, here's where we would be able to put in the static pressure, and it is important to put in the static pressure because this is what would be turned into 4 inches, as my guess, is an input that would then turn into motor heat, which would be dumped into our airstream. So it's good to think of that. Okay, coils. Moving on, we're moving at the speed of light. Here we can start to see these capacity overrides. For the air system we've chose, you don't need to look into these. We'll talk about that if and when you want to do chilled beams or radiant in the next video. Diversities. This is a very important field. Diversities define how much heating and cooling, or how much heat from these 3 items, people, lights, and plugs, is present when the entire building is peaking, or when this coil in this system is hitting its maximum. We'll have a whole nother video on diversities, but know that the system generally should have some diversity for these. People diversity refers to people's body heat. It does not refer to people's ventilation requirements. So, for example, if I took 50% diversity here in people, 1, it's telling me that that's a low number, and 75 is recommended. But what is going to happen is only 50% of the body heat will show up on the coil peak, yet we'll still have 100% of the fresh air requirements for all the people. Ventilation is done in a different spot. I'm going to go back to 100 for now. And let's look at the schematic. So schematic is what you would imagine. It's just a picture, nothing more than that. But I wanted to mention this dedicated outside air tab. So in this schematic, if we were to turn on dedicated outside air, if we were to say, yes, I have a cooling and heating, my system has a dedicated outside air fan attached to it. Let me put in some temperature so it doesn't break. This is actually not changing the system to be a dedicated outside air system. This is adding a whole nother system on top of my system. So if we were to look at the schematic, what I just did was I added a coil, a heating, a cooling, and a fan element out here. I still have my system's heating, cooling, and fan in addition. So this system still exists. I've now added a whole nother set over here. And if that was not what we wanted to do, and we really wanted this pathway to be 100% fresh air and not have two cooling coils, and we essentially just wanted this damper to be shut, we would do that a different way. I would actually recommend not doing anything here. I would change this to none. And under options, we could go to the advanced options and we could say, I want the amount of design airflow when you figure out how much air is needed for cooling or heating. 100% of that will be fresh air. That will now make the entire system a dedicated outside air system. I'm going to hit cancel because I don't actually want mine to be dedicated outside air. So that was a fly-through of the systems. Feel free to go back and check some things out. I'm going to go ahead and keep moving. We're going to close this and we're going to assign some rooms to our system, and we're then going to run it and talk a little bit more. So I hit the assigned zone rooms. In here I can select all my rooms. I hit shift and I click and drag them over. All these rooms are now under that system. There's a way also to make a thermal zone. A thermal zone might be useful for defining a branch of a building. If our building had a major east facade or an east corridor and a west wing, and we wanted this west wing to be known as that, we could say west wing, and it might have multiple rooms underneath it. A zone in Trace is nothing more than another report that Trace will spit out. So we're going to look at reports later, but if we were to set it up like this, we will get a peak report for when each room is peaking in terms of its cooling and heating needs. At this point, we'd also get another report when the west wing peaked, and that would be the coincident peak between both of these zones together. And then we'll get another report when the system peaked, which will be the coincident of when all of these zones peaked with each other. I'm going to move back all the rooms directly underneath the system. That's the most common way. I rarely see thermal zones used except on a large building, maybe over 100,000 square feet. Okay, so I've assigned my rooms. It's as easy as that. We're going to hit close. At this point I'm going to save. And, well, I'm not going to calculate. All right, I'm going to stop there, and next we're going to talk a little bit about some unique